Okay, well, thank you to the previous speakers for very interesting talks. I'll be continuing on the theme of school choice, talking about some very applied work we did to help design school choice for diversity in the San Francisco Unified School District. So Aram has set up a bunch of the definitions for me, which is great because I was going to go through them fairly quickly. So thank you. Before I begin, I just wanted to acknowledge that this is work with a very large group of collaborators. There are some of those who are acknowledged as co-authors of the paper, but also I just wanted to thank the many people at Stanford and also at the school district who were involved in things like helping us come up with definitions of diversity, helping us run simulations, helping us estimate the choice model. There are a lot of pieces that went into this work. Okay, so the problem I want you to have in the back of your mind is that schools across the US are resegregating. Today, in the interest of time, I'm just going to show you one cut of the data. What I'm showing you here is the percentage of Black students in minority schools. These are schools that are comprised of 90% or more racial minorities. Okay, and I'm showing you this aggregated for West Coast schools. And you can see that this percentage has been decreasing since school segregation was first ruled unconstitutional in Brown versus Board, but then increasing again since the 80s. Okay? Happy to talk offline about potentially what might have been happening to create this kind of pattern, but this is very common in all kinds of statistics, and this is just one example. And so a reason we might be worried about this is that there's recent research from the Stanford Educational Opportunity Project that says that when we have the confluence of racial and socioeconomic segregation, that is racial minorities concentrated in high poverty schools, this is highly correlated with very large academic achievement gaps. Okay, and so what we're going to try to do today is start to tackle this issue of school segregation using student assignment policy. And this is where the process via which students are assigned to public school. And so many of you are probably familiar with just neighborhood assignment. Here, students are just going to their closest or neighborhood school. But the type of policy I want to talk about today is in line with the previous talk, school choice, where students are given the option to submit preferences over schools all over the district, and those preferences go into an algorithm, and then the algorithm determines the assignment of students to schools. Today, I'm going to focus on a particular case study in the San Francisco Unified School District, which I will shorten to SFUSD. I'll talk about how we drew on all of this theory that we've been talking about today to suggest potential policies for the district. And then I'll tell you how our suggestions and optimization and simulations informed the approval of a new policy for student assignment that was approved by the Board of Education in 2020. Okay, so going into the San Francisco context, here we're thinking about assigning elementary school students, so about 5,000 entering kindergarten to about 70 programs at about 50 different schools. Okay, and here's a map of San Francisco just to give you a sense of what we're working with. And so school choice has been introduced for many reasons, and in San Francisco, it was introduced in 2011 with one of its goals being to help reduce segregation in schools. The idea is that the neighborhoods may be very segregated. You can see here a map from the census where the different colors are the race of the family, and we're kind of each family is a dot. And the idea is that if we let people choose to go all over the district, then we can hopefully disentangle segregation at the school level from segregation at the neighborhood level. Just to say a little bit more about segregation in San Francisco, the previous plot was racial or ethnic segregation. Here I'm looking at socioeconomic segregation. And in many cities across the US, segregation is a product of a systematic kind of biases and injustices that were enacted many years ago. So for example, on the left, I'm showing a map of redlining from the 30s. The red blocks are those that in the policy of redlining were systematically denied access to mortgages, other financial support. And you can see that this really correlates with the location of the yellow dots, which I'm showing on the right-hand plot. These are the percentage students who are eligible for free or reduced price lunch and is a measure of socioeconomic need. Okay, so we have this long history of just residential segregation, a lot of it kind of systematically enacted. And the question is, well, can choice help with this? Okay, and the short answer is kind of no. Or at least since 2011, choice has been used in San Francisco. And let's take a look at how our schools are looking in 2018. So let's look at the right-hand plot. As school choice was being used for those 7 years, we can see that my socioeconomic segregation at the school level still reflects socioeconomic segregation at the residential level. Okay, in particular, in the background, the heat map is just a different way of representing the same data I had on the previous slide. I've taken the percentage of students who live in that attendance area who are eligible for free reduced price lunch. And on top of that, I've superimposed the red dots, or the 50% of schools which have the highest percentage of students attending the school who are eligible for free reduced price lunch. And you can see those red dots are basically above the dark red areas. Okay, and so that's the problem that in 2018, the San Francisco Board of Education wanted to address. They resolved to redesign student assignment to improve diversity, but also a few other things, such as predictability, so that parents could have some certainty about where their students were being assigned instead of potentially going anywhere to one of those 70 programs over the district, as well as proximity, so that families wouldn't have to travel very far, in particular because this particular district does not have a very strong busing program. And so if we look at the policies that have been kind of discussed historically in education policy, we have neighborhood assignment, which faces the challenge of residential segregation, and then district-wide choice, which we show in our simulations actually faces the challenge of choice-driven resegregation. Okay, and so what the district had decided before we even began working with them is that they had these policy concepts. In the interest of time today, I'm not going to talk too much about concept 1. I'm going to focus on concepts 2 and 3, which were essentially to restrict choice to small and medium-sized geographic zones, respectively. Okay, I'm going to draw these boundaries, and if you live in the boundary, you get to go to the schools in that boundary. Okay. So let's take this policy idea and see what the literature has to say about it and see how it might perform. First, let me just go back to why we're focusing on this particular problem of school segregation. I mentioned this work on the confluence or the correlation between racial achievement gaps and also concentration of poverty and racial minorities. If we think about this concept of zones in particular, there's a lot of evidence showing that just the geography of inequality is very common in schools, and zones themselves have historically been gerrymandered the opposite way to kind of give more to the families of more means. As we mentioned earlier, we have some simulations that also show that families are often choosing in ways that kind of do resegregate. Okay, so there's a lot of things going on here, which means that we might want to take a more principled approach to designing the student assignment process to kind of push back against these forces. And so how might we do this? I'm going to be drawing primarily on the school choice literature. And so this has been described for me very well, so I'm going to go through this very quickly. The main idea is we're going to use these mechanisms, which are algorithms with strategic input. Mechanisms include, deferred acceptance, top trading cycles, and they're used in many cities already. And the main tools that are used in these mechanisms to help kind of control the distributional outcome of students, there's often the talk of using priorities. We just give priority, for example, to students who we want to have more access. There's also work looking at menus. Menus essentially restrict the choice of students. And you can think of our zones as being a particular kind of menu that restricts geographically. And then finally, the reserves that were discussed earlier are a very common way to try to achieve diversity. And so our first step was to kind of expand beyond policy concepts suggested by the district to kind of build on this theory. And so there are a couple of considerations which I'm happy to talk about offline. For example, which mechanism should we use? The mechanism that they were using was, something that they thought was top trading cycles. We looked at the pseudocode, decided it wasn't, talked to them about the difference between deferred acceptance and top trading cycles. They decided they liked deferred acceptance more. Really interesting backstory here. I'm happy to talk more about it offline. Fun fact, what they were using was very clearly not strategy proof. We also had a couple of other conversations, simulations to kind of look at, well, what about concept one? What about things that have been done in other districts, such as the Boston personalized menu idea? But what we finally decided on was the following. First, just their concepts 2 and 3. Let's use zones purely. Second, let's draw on the literature and build in some reserves. Third, let's also use the literature and the optimization machinery that was set up in Boston to kind of look at menus. And so what I'm showing you today is not optimized menus. We're still working on that. But this is just sort of heuristic menus that were chosen for interpretability and alignment with goals. And finally, again, just let's take the standard school choice approach of using priorities to do everything. Okay. And so the first question we had to answer is, which zones are we going to use? We used an optimization approach, a two-stage optimization, where first we took building blocks, those attendance areas I showed you earlier, and we used an integer program to piece them together to generate zones satisfying certain size, shape, and balance constraints. And so, for example, you can see some of these constraints here. Size could be, do we have small zones or medium zones? Shape constraints can include how compact is it? Does it look nice and circular or kind of snaky? And how contiguous is it? Does it all fit together in one piece, or are there islands like this? On the bottom left, you can see the purple zone has 3 islands, and so that's non-contiguous. We also have a lot of other balance constraints, for example, students across zones, seats, and student match, diversity constraints. And all of these constraints you can see are just at the zone level. So that was stage 1. We want kind of representativeness at the zone level. And then in stage 2, we then simulated choice on these sort of the Pareto frontier of these zones that were performing well at the zone level. And then we measured outcomes at the choice, after choice at the school level. And kind of combining those into one huge optimization problem is something we're also currently working on. Okay. And so all of this went together into a kind of end-to-end policy decision support tool that we built, where kind of the main theorist question might be, well, how do we think about the mechanisms? How do we think about the policies? But there were also a lot of pieces that went into predicting choice, some of these which go beyond the current practices in sort of the school choice literature, and then also a lot of evaluation. So coming up with metrics with colleagues from the education school, building all kinds of visualization tools for staff to work interactively. Okay, so in my final few minutes, let me show you some of our results. Okay, and these results were simulated using historical data. We have data on students' preferences and also which schools they were assigned to, and we can also see enrollment the following year. And what we did is we took applicants to kindergarten for the 2018-19 school year. We estimated both a choice model, a utility model, so how much would they like the schools, and then also an opt-out model. If we assign them to a school, will they enroll or not? Using aggregated historical choice data. And everything I'm showing today is averaged over 100 realizations of randomness in the lotteries and also this random utility model. Okay, so as a reminder, what were my policies? I have my home-based policies, I have my zone-based policies, I have this sort of benchmark that school choice literature likes to talk about priorities, and I also have the benchmark of the actual assignment in 2018-19. And I'm going to compare them across, I'm showing you here one representative metric for each of diversity, predictability, proximity, and choice. We looked at many more, happy to talk about that offline. But the thing I want to concentrate on is just kind of the heat map, the colors. You can see kind of this clear green diagonal, right? Which shows there's a very clear trade-off between these goals. And so just to walk through some of these trade-offs, our zones and reserves and priorities are both able to really reduce the percentage of African American, Latinx, and Pacific Islander students assigned to these 67% FRL. This is 15% more students eligible for free reduced price lunch than the district average. Okay, so there's some kind of concentration of racial minorities in these higher poverty schools. You can see that percentages decreased from 29%, more than halved, to about 11 and 13% using these two policies. And surprisingly, the policies that kind of restrict your choice to closer schools do better on distance. The interesting thing to point out is that distance actually goes way up under priorities. And then also, unsurprisingly, all these policies that restrict choice end up with fewer students getting their choice. What's interesting is kind of the magnitude of this. And so one potential drawback is that if, let's say, as a very kind of naive first cut, we say all the students who were assigned to something not on their rank list, okay, we just kind of assign them, the process called designation. So we designate it to something not on their list. Suppose all those students leave. Okay, then this wonderful diversity metric we had before actually becomes worse, significantly worse than the the status quo. Okay. Despite this, the district said, well, actually, this column here, zones and reserves, are achieving all our district goals of diversity, predictability, and proximity. And so this was the policy that they wanted to go with. And so just to kind of dig into the choice thing a little bit, we've been working on doing a more accurate prediction of which students are going to actually not enroll. We see, surprisingly, and we've heard about other districts seeing the same, that where the students are assigned does not affect opt-out that much. And so just to kind of flash, and this is the background heat map is now with the after opt-out, and you can see that we still get this sort of same green diagonal, and most of the numbers are not changing too much. Okay. And so in 2020, the proposed policy was to restrict choice using geographic zones, use reserves to improve diversity, and also added this thing called equity priorities. And this policy was approved in 2020. There are a bunch of challenges, next steps, follow-up questions. I'm happy to discuss any of these offline. Thank you.
Yeah, we have like, once again, 3-4 minutes for questions, so let's go ahead.
Thanks. Thanks, Irene. I really liked the analysis for the opt-out, but I didn't understand at the very end because it looked like diversity decreased by 40% and then it increased by 11%. That column, yeah, between those two slides.
Yeah, great. So here I'm predicting opt-out using two different kind of approximations. Okay, the first is, let's say I just remove everyone who did not get one of their listed choices as we predicted using our choice model. If we remove all of those students, then we see that a lot of essentially what happens is a lot of the students of means we predict to leave. This means a lot of schools become high poverty schools, which means that a lot of racial minorities end up assigned to these predicted high poverty schools. Okay, what's going on here? First, in the percentage is not the change. The percentage in the parentheses is not the change. It's just the new okay. So actually, it's staying the same. 11%, 11%. Okay, essentially, why is it staying the same? We haven't really gone into understand why, but here are some hypotheses. First, as I mentioned, which students opt out actually does not depend very much on their assignment. Just to give one piece of anecdotal evidence, there's about 5,000 entering students. At the end, about 1,000 of those opt out, so 20%, very high. But 400 of those who opt out are students who received their first choice assignment. Okay, and so yeah, these are students who are just going to opt out anyway. And so we're using, we don't have sufficient data to do a really good job on predicting who will opt out. But what we do is we use the data we do have. We use regression tree models to kind of see which features are most predictive of whether you'll opt out. And things just like your income, your race, where you live, those things are way more predictive than how highly ranked or popular the school is that we assigned you to.
So I know that we said that there wasn't, students aren't opting out that much and this is for kindergarten, but for high school where students tend to go to private schools kind of more, could we expect similar patterns?
Good questions. The question was about, well, what if we're looking at high school? So first, what you said is that in high school, students tend to opt for private school more. I'm not exactly sure that's the case. A lot of students in kindergarten are also opting for private school. And so what we're seeing is that your choice of whether you go to private school at the kindergarten level depends less on your public school assignment. It's more you entered the public school choice system because all those systems start super early. At that point in time in December, you don't know if you have a private school option, and so you just kind of enter. And so it's not clear to me how much that dynamic would change if we move to high school. The other thing I'll say is, like, all of these results are super sensitive to the San Francisco context in particular, right? And so I don't want you to index too much on our findings if you want to generalize to other districts or, even high school, a different school system within the same district, but more in our process. And yeah, I think it's impossible really to say anything about any other school system other than the one we analyzed.
Thanks so much for your talk. Just a question on the zone drawing. So it sounded like you're taking existing attendance boundaries and you're combining them to create zones. Did you consider drawing zones from scratch?
Yeah, great question. So most of the methods for drawing zones involve using some kind of geographic building block. And so currently we are using smaller building blocks in the attendance areas. For the policy decision, we use attendance areas, which is why I'm showing you this today. But we're currently using block groups to redraw zones, and they look quite different. For example, you might have noticed that the set of zones we chose, I never showed you the set of zones we chose that we used to draw this map. Okay, anyway, so if we look at these zones, a lot of them look kind of like skinny and snake-like, right? And once we use the smaller building blocks, that no longer is the case. I think we're out of time.
The next questions outline, and we're going to go to the next speaker, but let's thank Irene again.